Hello everybody and welcome back to the Technical School Kovacevic. Today, a fellow peer student is preparing some experiments for us in a laboratory, so let's peek inside. When an aldehyde is added to Toland's reagent, the aldehyde is oxidized to form a carboxylic acid and the diamond silver ions are reduced to metallic silver. The diamond silver ions are more difficult to reduce than silver ions. It's made by mixing a Toland's reagent and an alkyne solution. It is a colorless solution of a diamond silver complex. We first poured Toland's reagent into the first tube and placed it in a glass beaker that was previously put on a heater. We then, in a separate tube, added glucose and water. When we poured the mixture into the Toland's reagent, after some time, a silver mirror is formed. Toland's reagent is also used to apply a silver mirror to glassware, for example, the inside of an insulated vacuum flask. The underlying chemical process is called silver mirror reaction. The reducing agent is glucose, an aldehyde, for such applications. Clean glassware is required for a high-quality mirror. Hydrogen peroxide is first mixed with a liquid soap or a dishwashing detergent. Then, a catalyst, often around 10 milliliters of potassium permanganate, is added to make the hydrogen peroxide decompose very quickly. Hydrogen peroxide breaks down into oxygen and water. As a small amount of hydrogen peroxide generates a large volume of oxygen, the oxygen quickly pushes out of the container. The soapy water traps the oxygen, creating bubbles, and turns into foam. How rapidly the reaction occurs will depend on the concentration of hydrogen peroxide used. This experiment shows the catalyzed decomposition of hydrogen peroxide. Hydrogen peroxide decomposes into water and oxygen gas, which is the foam itself, but normally the reaction is too slow to be easily perceived or measured. In normal conditions, this reaction takes place very slowly. Therefore, a catalyst is added to speed up the reaction, which will result in rapid formation of foam. The iodide ion from potassium permanganate acts as a catalyst and speeds up the reaction, while remaining chemically unchanged in the reaction process. The iodide ion changes the mechanism by which the reaction occurs. Under the influence of vinegar and alcohol, amylase from the spit reacts, aka it separates from the spit and only DNA remains. It isolates itself. We can see that as the spit's density grows. That is because the amylase has been extracted. It gets a string-like shape, and then, as the DNA is fully isolated, it gets a slimy, dense shape. We hope you enjoyed today's experiments and that you learned something new with us. The last experiment is a small preview of the new educational profile that will be added in September. It is a welcome for our future forensic technicians. I hope to see you soon.